Hello, welcome everybody to another wonderful workshop for the Internet Computer BUIDL Bitcoin Hackathon. After the amazing launch on Monday and another cool workshop yesterday, we're here for the third workshop, this time by Severin from the DFINITY Foundation, who will be teaching you something about building canisters with Rust. Before I hand over to Severin, just a quick reminder that you can still sign up for Hackathon. I'm pasting the link over here in the chat. Feel free to fill out the form, and that's it pretty much. So Severin, feel free to take it away as soon as you want.
Okay. Hello, everyone. I'm Severin from the DFINITY Foundation. I'm a software engineer on the SDK team, meaning we build tools such as DFX or the Rust CDK, which we will use in this session. Here's what I will talk about. First, a tiny bit of why you maybe would like to use Rust. Then we'll go through how to set up a Rust project, how you can manage state. Then we call other canisters. And then with the remaining time, we'll cover useful features that will make your life easier. Why would you like to use Rust to build your canisters? First off, Rust gives you pretty low-level control over everything your canister does. If you ever want to go down to the unsafe level of Rust to do whatever you want to do, you can, even though you probably shouldn't. Then you have a gigantic ecosystem of crates. IDE tooling is pretty nice. And this makes it really easy to get going with building your canisters with the functionality you already know. In comparison, Motoko, that ecosystem isn't quite as large yet, for example, for encryption or encoding, decoding. There's quite a few holes that still need to be filled. Then, for some of you, Rust will be an already familiar language, and that just makes it easier to get started. Why should you not use Rust, or when should you use something else? I think the biggest reason to not use Rust is if you don't know it already. It is a really hard language to get started, and especially for building canisters, you just need to do some relatively weird things because Rust wasn't built for building canisters. Quite a few things like managing state are pretty tedious, and while I like some things about it being tedious because it makes it easier to spot certain kinds of errors, you may be annoyed by it pretty quickly. Also, because it has those special things, what you're used to or how you're used to writing Rust may not quite work, which may throw you off. So if you mix up concepts easily, maybe you shouldn't use Rust. With that out of the way, let's go build a canister. I'll just jump over to my IDE. There we go. Now you should see my IDE. And here we have what you can build with this is the command you can use to create a similar project to this. This is exactly the project this produces, just with everything that I can remove stripped as well. I am assuming you already have DFX installed, you have Cargo installed, and that you're familiar with Rust. You don't need to be an expert in Rust. I'm not one myself either. But you shouldn't be surprised by what a mutable reference is or something like that. For this workshop, I'd like to build a toy example, a simple counter canister. For building my Rust canisters, I like to split the canister interface, or the code that actually makes your code be a canister, and the logic inside the canister separately. This makes it easier to test your code because then you don't always have to spin up a canister and a WASM runtime or a full-blown replica with DFX start. So let's start by creating a simple state machine. And here I'll just paste a bunch of code in, because otherwise typing it all out would be way too slow. So our canister will have a really simple state. We just have one variable, the counter. We are using a different type than you're usually used to. The lingua franca of the Internet Computer is candid. That's just the language every interface is described in. And because we want to make it as simple as possible, we just use those types directly to build our canister itself. Nat is short for natural number. So any integer as you know it is the same. Then, just as convenience for our tests, we have a default implementation, and then we have the basics of our counter. We can read the counter, we can increment, or we can set it to a certain value. And to show you why exactly we're separating things between logic and interface, here we have a test where you can see how easy it is to test this state machine. You can really simply use the methods as you're used to. If we were to do that in the canister interface, things would get much harder than that. Okay, let's see if that builds already. Okay, you may have to fix some imports in your project, but that's just a matter of defining your dependencies normally. Those should be ready to go from the DFX new, but I'm sure you can figure that out on your own as well. Now that we have the logic in the state machine, we can turn that into a canister. Here is the code for the very simple Hello World example that you get from DFX new, but we will replace that with first a bunch of imports, and then we will create our canister state. To keep the canister state, we like to use a ref cell within a thread local. That's just the way we have found out it is easiest to manage your state. We can use the thread local because canisters are single-threaded, so therefore we can just forget about any multi-threading problems. And the ref cell doesn't make any problems with that either. It's not very beautiful. I don't like how tedious this gets, but it works, and it also makes it relatively easy to notice re-entrancy vulnerabilities, which are some of the most or in my experience, some of the most destructive if they get exploited. Let's see. Here we go with the imports. There we go. For the workspace, I define those because later we will create another canister, which is a separate project. And then here are, whoops, tabs are hard. Here's how we inherit those dependency version numbers for our canister. I put in a few more that we use later, just so I don't have to do that again. With that, we should be able to run cargo test. And there we go, everything compiles properly, even though for some reason, now it found out that that's fine. Okay. So this is how we keep the state. And now we have to make that accessible to the outside. We will start with just the increment method. For this, you define your function increment. And then you take the state. With width, you go into the thread local. And then you have the ref cell state, which you have to borrow. And then you can call increment on it. This is how you pass control flow through to your state machine that we defined over here. Then, to make this function accessible from the outside of your canister, we have to annotate it with those two annotations. I'm not quite certain which one does which, but one of them is to expose it in the canister interface, and the other one is for the candid crate to handle serialization and deserialization. Then in Rust, it's sometimes a bit of a manual process. In DFX.json, you can see that the Rust package is already defined here, but the candid file, that usually doesn't get auto-generated. So we have to adjust that as well. I just paste in all three functions, because if we don't try to access them, it doesn't matter if they don't actually work yet. But if you don't have the proper candid file, DFX will complain that your canister isn't actually compatible with the interface you want it to be. Now with that, we have our canister and we can start DFX. This is the command you will use almost all the time. I even turned it into an alias, so I just have to type dscb because I use it a dozen times a day. Now we can simply deploy our counter canister. This will create canisters on our local network. Then once the canister IDs are known, it will build the project, and then it installs the code in the canister, and then it's accessible from anywhere you can access that replica. We can now call the increment function on this canister, and we get a unit back because right here, the function has no return value. But since this is not an error, that means everything worked just fine. I think this is a great place to make a first break for questions, if there are any.
Yes, there are a couple. The first question from Artem is it possible to link Rust modules compiled to WASM from Motoko?
I don't think yet, but I just saw today some discussion on Slack that the Motoko team is very interested in that. I think the interest is mostly in the other direction, but yeah, I don't see why it wouldn't work that way either. We just don't have the default workflow for that at the moment.
Yeah, just to clarify, Artem also clarified that they're asking about linking WASM modules directly rather than calling canisters, if that helps with the question.
Should work. I don't know how to. As I said, I'm not that great at Rust.
Cool. Okay, another question from Zanyar is about calling functions. Is there something like a message.sender or any similar command?
Yes, Berat already explained it correctly. You just use the function like this. And this will give you the principle of the caller.
Okay.
Yeah.
Yeah, go ahead. Amazing. Do you guys have any more questions?
Otherwise, I'll just continue, and
yeah, I think
we'll take another break in a couple minutes.
Thank you. Go ahead.
Okay. Now that we read the value, we can make the next method, which is the same but a little bit more complex. This time, we take an argument and use that to do something. Again, almost the same. Go into the thread local, go into the ref cell, and then you can just pipe that through. I'm not even gonna demo that because that's yeah, should be obvious how that works. Now, reading the counter is a bit more complicated. Maybe let's start with a simpler version. I'll just comment that out. So this time we make it a query function. So people can also call it in non-replicated mode. Query means that either it can be called, or both, that it can be called in non-replicated mode, and that whatever changes it makes to the canister state, those changes will be discarded afterwards. So usually it's used for simple read functions, but you are allowed to do quite destructive operations to your data structures because the changes get thrown away afterwards. In this case, that's not necessary, but it may be useful for you sometime. So, since a canister cannot return references, we always have to return an owned value. Meaning, for a simple read, read request like we have it here, we have to clone an object. Once we return that from the function, the Rust CDK will serialize that into the serialized candid format and send that out. This clone is unnecessary. While it doesn't matter for small values like the candid net, for larger ones, that may be quite a big problem, especially once you get to the limits of your canister memory. Because of that, there's the thing called manual reply. You can simply wrap a reference to a value in a manual reply struct, which will then directly serialize to candid without having to go through the clone. You don't have to do that until you get to the limits of your canister, but you should be aware that that's a way to optimize if you run into the limits. Just note, you have to say in the query annotation that you want to do a manual reply. Also, if you reply more than once, your code will panic. Now we are ready to test that. So I will redeploy. And then we can get the counter, increment, and get it again. And the set function also works, as you can see here. And that's the super basics of how to write your canister. Let's see again if there's any more questions.
Yes, there's another question. Could you clarify the non-replicated mode?
Okay, so as you all may know, blockchains can be a bit slow. Bitcoin, for example, takes 10 minutes per block. The internet computer is a little bit faster. It makes 1 block per second. And your messages need to go through 2 blocks to get a response. So your requests usually take 2 seconds or more. This, or the people designing the internet computer decided that's not acceptable. So they said, how about just 1 machine replies to your call? And that's the non-replicated mode. You send a request and you just want 1 machine to execute it. This means the request is not secure, so you shouldn't trust it unless you have other measures in place, like certified responses, which I won't go into in this presentation, or you just execute it 5 times in parallel, so you can hope to spot if one replica returns a forged response. But in simple terms, it's the fast mode that's just not as secure.
Amazing. Thank you. There's another question in the questions tab. How can I deal with the USDT transaction? So I must, yeah, go ahead.
That's so USDT, that's a currency in the Ethereum ecosystem.
I guess they're asking if there's any interaction between the
not yet, but you can find the latest, or Ethereum integration is in the works, and you can find the latest state of that in this thread. It's still a bit away for the first version, but it's relatively close now.
Okay, amazing. I hope that answers your question, Ali. There are no questions, any further questions right now, so I guess you can proceed.
Okay, now with the super basics, we have to go to the next big topic, interfacing with other canisters. Otherwise, well, it gets a bit boring. Since we have a super simplistic toy example, let's keep it simplistic as well. We will just make a proxy canister that forwards requests to our counter canister. So we just copy paste our counter canister, rename it to proxy. Let's see, folder, package. Then this canisters cannot do query calls to other canisters, so we have to turn this into an update call. Then we don't need a state machine. And we have to add the proxy canister to DFX.json. And now things work or they don't, because I may have forgotten something. All the state management we can throw out. There we go. Small note for your DFX.json. If you declare a canister that depends on a different canister, so it wants to call that canister, you have to declare it as a dependency. Otherwise, DFX will not expose that canister ID during the build process, and you cannot properly build your canister. Now, to import another canister, it's as simple as that. We can use the annotation import and then use the same string here as we defined here in DFX.json. Whoops, I just noticed that's on the wrong level. There we go. This will import all functions that are defined in the candid file as Rust types here. So if we want to make the first proxy function, it's as simple as that. Again, the update call annotations, function name we want to have. This time we need to be in async land because we have to await the other canister's response. And then we can just use a struct from up here and the get function as defined here. Await the result. And then, because we're in candid land and in candid everything is in tuples, we just take the only member of the tuple and return that. Let's fix imports. And that is fine for now, that error. And let's see if I forgot something. Looks to be all good. So if we check what the counter's status is, we get 20. And now if we call the same on the proxy, it takes a little bit longer, but we also get a number 20. And if we increment, the proxy also gets the updated value. So all those red squiggly lines, I hate those. I don't like those to appear when I didn't do anything wrong. So let's fix that. One way to do it is to say, hey, that only happens if we're compiling to WASM. This fixes the squiggly lines here, but we still don't have that. So let's add another thingy. If we're not in WASM land, let's just claim we have this canister ID. That's a valid canister ID, but not the right one. And then we just say, hey, here's the canet file. Just use that and simulate this canister ID. That's going to work just fine. And with that, everything compiles properly. This is also important if you write tests, because otherwise, if you just run cargo test and just want to run this test, if things don't compile over here, that also doesn't work. And that's already inter-canister calls. Any questions so far?
Yes, so we have a couple of new ones. So Matt is asking, I don't know, this isn't directly related to us, but is it possible to create a front-end page with React or Vue or Angular and deploy it on the ICP?
Yes, in principle, you can use any framework you want, but they're not quite all as easy to start with. The easiest place to get started with those is over here in our examples repo. There you have React Native and Svelte starting templates. But if you search on the forum, you should also find other ones. I think Jordan, who did the first workshop about ASL, just created a Vite starting project, I think. And there should be a few more out there as well. But don't ask me too much. I have no clue about front ends.
That's completely fine. And yes, Jordan did share a bunch of examples back on Monday, and thank you for sharing the GitHub repo once again. There was actually a question earlier about examples of using front end with the ICP, and you answered it without me even asking it. I think that Behrad is typing a question, but I think yeah, this is pretty much it as far as the questions go right now, so you can proceed.
Okay, let's see what's most useful. I'm just looking at the time. Now I have to decide which is more important. Okay, let's see about upgrading canisters. On the IC, you can update your smart contracts. On Ethereum or most other blockchains, you have, that's just not possible. It's written in there for eternity, and people have created some workaround solutions and so on. But on the Internet Computer, you can just update your smart contracts by default. Now, when you update your code, your heap gets discarded. That is because if you change your code, most likely your functions aren't in the same place anymore, and you may not have the same data structures anymore. but we would still like to persist some data between upgrades. For that, we use a thing called stable memory. You can think of it almost like the disk. So before you do an upgrade, you have to serialize your data to stable storage. And then once you have upgraded, you have to deserialize it back into memory. If you don't want to do that, you can also use a data structure that already writes to stable memory. Those are not as convenient yet as I would like to see them. But if you work with large amounts of data that exceed the limit of normal memory, then you have to use those anyway. I think the search term you would want to use for that is I see stable structures on the forum. Anyway, let's talk about the normal way. Technically, you can serialize in any format you want, but it's easiest if you just reuse the candid we already have. I will make the update or the upgrade function for the counter because that has state that's actually worth keeping. For upgrades, we have two functions that are important. Those are called pre-upgrade and post-upgrade. In pre-upgrade, we write the state to stable storage, and in post-upgrade, we put it back into normal memory. So first, we have to get the state out of the thread local and the ref cell, which you can do with the take function, and then you have an owned state. Then you can simply save that state. Here you can maybe see why we put everything into one struct called state. That just makes the storing much easier. If we have more things like the owner or so, that just works out of the box. Again, we're in candid land, so everything is a tuple. And that's all we have to do to store things in stable memory. Then to put it back into main memory, we have to do stable restore and give it the type that it will deserialize to. Again, candid, it's tuples, so it will turn into a tuple. And then we have the initial state, which we borrow and replace. And that's all that you have to do for basic upgrades. Here it is actually okay to just expect anything, because whenever anything goes wrong during pre or post upgrade, the upgrade gets reverted and your canister will act as if it was never upgraded. Now, small warning, if your pre-upgrade panics, then your canister may be unupgradable. There are really hard workarounds for that if that happens to you, but it's better to just not let that happen. Yeah, I've heard some pretty painful stories around figuring out how to upgrade anyway. Workarounds aren't properly supported yet, so please take care with the pre-upgrade function. Post-upgrade doesn't matter that much because that gets called from the newly installed code, which you can always fix if you need to. Any questions about upgrades?
Seems like no specifically about this, no questions right now, but there are a couple of other ones, or actually just a general discussion in the chat. I don't know if you want to address this now or later on. The discussion is about you're not an expert on front end, obviously, but about deploying the front end on chain and in the canister itself, and not separately from the canister. Could you address that?
Yeah. So in parts, it's a matter of taste. I like to have everything in the same place because it's just easier. I like my DFX deploy to do everything for me. I can see talk about blocking access to canisters. The DFINITY run boundary nodes do block some canisters that don't behave. For now, it's almost exclusively phishing sites that get reported left and right. I've seen dozens of fake Microsoft login pages and so on. Yes, DFINITY does block those, but things are in the works to get alternative boundary nodes available so you can host your own and expose all those phishing sites on your domain if you want to. While I don't recommend it, you can do that. As of now, I don't think, or I think technically it would be possible to prevent any calls to canisters, but for now the boundary nodes only block HTTP traffic. So even if your ASIC canister gets blocked on a boundary node, you can still access it through DFX and change its contents or back up whatever is in there. So I don't think it's that much of a problem as people make it out to be.
Amazing. One other question that kind of came up during this whole discussion in the chat, which is very wonderful to see, is how decentralized is the ICP as opposed to other blockchains?
That depends on how you look at it. The place to go for that is the dashboard. There you can see right now there are, where is it? Things have moved around since the last time I looked at it. There we go. Total node machines, 1,200 right now. 1,200, that may not sound like much to some of you. I think that's quite a lot. Those nodes are hosted from 85 different node providers. So we have 85 different parties that supply machines to the IC. Those are legally distinct entities, and each subnet has 13 machines, each from different node providers. Yeah, now you can say 13, that's even less. But if we look at something like Bitcoin mining pools, there you can see that actually only 2 or 3 mining pools together control Bitcoin. So if those pools were to combine their forces, they could take over the Bitcoin network. Here on the IC, it would take, 5 node providers to work together to stall a subnet. And while the mathematical guarantees are not there, I think it would take 10 of them to collaborate to actually perform malicious operations. But even if only one node deviates, a bunch of alerts will fire and the team would very quickly investigate and stop that subnet. So in my opinion, it's pretty well decentralized. We're onboarding new node providers, I think weekly at the moment. So yeah, it's only getting better.
Okay, amazing. Yeah, I think that you can go on with your workshop right now to the final. Actually, we have 15 more minutes left, so you can go towards the end.
Okay. Then let's go on with a little bit more upgrading canisters. There are data types that are not candid serializable. If we look at the state, it derives candid type. Any type that implements candid type can be serialized by the default candid functions, such as stable, save, and restore. Some types do not import or implement that. For example, a B-tree map. In these cases, you either have to implement candid type yourself, or you first have to turn your state into a serializable state. That's what we do, for example, in our asset canister, where you host your front ends. And you can do that yourself pretty simply. I have an example here. Let's paste it at the bottom. Excuse me. So here we have such a non-easily serializable state. Just to show you, this will not work. Yeah, once the imports are fixed, of course. Oh, never mind. By now, B-tree map implements candid type. So let's just imagine it wouldn't. Then you have to first turn it into a serializable state, like this, where you have, for example, a vector, which back then was the only way to get a B-tree map to serialize. And then you have to implement to and from, or just some way to convert between the two. Usually it's relatively straightforward, just like here. And then when you take the state, you would then turn the state first into the serializable state and then save that. And in post-upgrade, you just do the reverse of that. It's nothing too spectacular, but it's easier if you hear the concept before you run into the problem. Any questions about that, maybe?
Yes, actually, a couple of questions. Armando is asking, what do you recommend to do backups of the data with?
That's sort of an unsolved problem. The feature to do full canister backups is relatively high on our list of things you would like to work on. So things will improve soon, I hope. For now, you're mostly stuck with manually exporting your data. So I would recommend you add a bunch of query methods so you can export your data, ideally in a paginated format, because responses can only be up to, I don't remember, it's either 2 or 10 megabytes. So if you have a bunch of data, you may have to do that in multiple attempts. Other people have written some utilities to export the full state of the canister for every single byte. I think that's a bit hardcore to do, but you can use the same solution for everything. If you search for backups on a forum, you will find a bunch of discussion on it, and yeah, you can see what the latest consensus on ideal methods are there.
Yeah, it's not ideal, but I guess the internet computer and the whole Web3 space is still developing, and I guess you'll see a feature for backing up in the near future as well. Another question from Zanyar is, how much have Rust canisters on the ICP changed since 2021? So roughly in the last 2 years.
I don't know. The library itself, or the CDK, the canister development kit, is relatively stable. There have been quite serious improvements to Candid itself, so serialization is getting better. Upgrade compatibility is improving, like you can do more things to your interface and it still doesn't break. But the very basics of Rust canisters haven't really changed. There have been some attempts to make more user-friendly libraries to develop your canisters, but most of them have stalled for some reason or another. I think the nicest one we had was a thing called ICKit by Psychedelic, but they have since stopped working on that project, while they still said they wouldn't recommend anyone to use it because it's not secure yet. Yeah, it's slow, but I'd say it's improving.
Lovely. Thanks for the answer. The next question is, if the canister gets out of the cycle for more than 10 years, what happens to it?
So there's a few things to say about that. First, okay. So a canister has cycles. Then the canister has a freezing threshold. The freezing threshold is a number or a time defined in seconds. Each canister has a certain amount of data that it currently occupies. So, well, combining that, for a certain amount of data, you pay a certain amount of cycles per time. The freezing threshold says if your canister has only enough cycles to store its data for less than freezing threshold amount of seconds, then the canister will be stopped. That's a really complicated way of saying there's a safeguard, and if you run or if you drop below the safeguard in cycles, your canister will be stopped, meaning it will stop accepting queries and update calls. Then once all those cycles still run out because you're still paying for the storage, so if the balance goes down to 0, then your canister will be uninstalled, meaning the code will be deleted, the state will be discarded. But you will still keep access to the canister for 10 years. It will just be a simple shell of itself. You can still reclaim the canister ID, but not what you had there before. This allows you to restore things. So if you have a project that others depended on, then you can still restore your project to the same canister ID. But the data is lost. I may have rambled a bit much, so if I didn't hit the point quite right, please ask again.
Yes, yeah, but I think you generally answered the question. So, but yeah, we'll see. The person who asked the question says, in my project, it is so important to get canister ID recovered. The data is not important for me.
Yeah, then your basically good to go. You can run out of cycles, no problem. Just make sure you still have keys for your principles so you still have the means to control that canister ID. If you want to, you can also add additional principles as controllers, so you can have backup IDs. You would do that with like that, and then the principle. And then this list of principles would grow by that one that you added. You can have a maximum of 10 controllers at any time.
Amazing. Yeah. Thank you very much for answering the question. There is one more question we can answer before we run out of time because it's almost 6 p.m. CET. The question is, what do you recommend if the person wants to build a website where people can deposit and withdraw cryptocurrencies? How would they go about building that kind of a canister?
I think the easiest way to start is to go to any wallet's website. For example, there's the Plug wallet, there's the Stoic wallet, there's I think NFID has a wallet. Yeah, there's a bunch out there. They all have really nice documentation to create a Hello World example where people can use their cryptocurrencies. Yeah, Plug wallet seems to be down. I'm not quite sure how nicely that's maintained, but Stoic wallet should be fine, I think.
Yes. Okay. Well, thank you very much, Severin. I think that will conclude with this final question. It's almost 6 p.m., like I said. Thank you once again for the wonderful workshop on building Rust canisters. I hope that
Before I
everybody.
forget,
Yeah, go ahead, please.
I have a list of places you can go if you need more help. I'll just put it in the chat. I forgot to add the link for the dev Discord. You can find it on internetcomputer.org. You can go to all those places if you need help. If you want to contact me directly, I'm on the forum, username Severin. I'm always happy to help.
Amazing. Cool. Thank you, guys. As Severin said, feel free to reach out to him and to anybody here at Encode Club or at the DFINITY Foundation. We'll be happy to support you in any way we can regarding the whole hackathon and with building your project. I hope to see you tomorrow, same time as today, for two further workshops. One will be by Orly, one of our education partners, and one will be by Rock Labs. Thank you, and once again, it's so wonderful to see all the discussion in the chat and people interacting and answering each other's questions. Yeah, thank you very much, and see you tomorrow, guys. Bye.
All right.